In this problem, we're going to solve the sine of 2 theta equals 1/2. And again, we have the domain restriction that theta needs to be greater than or equal to 0 and less than 2 pi. However, in this problem, we should notice that the argument is 2 theta, not just theta. So the first thing that we need to do is find the angles such that the sine of the angle is going to be 1/2. The sine of an angle is going to be equal to 1/2 in two circumstances, when the angle is in the first quadrant and when the angle is in the second quadrant. In the first quadrant, if 2 theta is equal to pi over 6, then we would get 1/2. In other words, the sine of pi over 6 is 1/2. So 2 theta would have to equal pi over 6 for the equation to be true. In addition, the sine of an angle is going to be positive in the second quadrant. So the angle 2 theta would have to be 5 pi over 6. So 2 theta would have to equal 5 pi over 6. Now what we do is we say that 2 theta equals pi over 6 plus 2 pi k, where k is any integer, or 2 theta is 5 pi over 6 plus 2 pi k. The reason that I know to do that is because the sine function is going to, this particular function, y equals sine of 2 theta, has period of just pi radians. So I go through 2 complete cycles of the graph between 0 and 2 pi. Therefore, I'm going to expect more than just these two as answers. What I want to do now is find the value of theta. To find theta, I divide both sides of these expressions by 2, and I get that theta equals pi over 12 plus pi k. And in the second one, I'm going to get theta equals 5 pi over 12 plus pi k. In other words, just continually add the period of the original function to the expression until you get all answers between 0 and 2 pi. So if we didn't have this domain restriction, this would be our solution for k any integer. So now what we're going to do is start listing out values of the angle for various values of k. For example, suppose we let k equal -1. Then I would get theta equals pi over 12 minus pi, in this case, or -11 pi over 12. That certainly is not in this interval, so it won't be a solution. How about for the other one? We would get theta equals 5 pi over 12 minus pi, or -7 pi over 12. That also is not in the interval, so it doesn't work. How about for k is 0? Well, for k is 0, I'm going to get theta as pi over 12 in this case, and I would get theta as 5 pi over 12 in the second case. Those are in this interval, so they're going to be these are two of my solutions. How about for k is 1? For k is 1, I get theta is pi over 12 plus 12 pi over 12, or 13 pi over 12. That's between 0 and 2 pi, so that's going to be a solution. I would also get 5 pi over 12 plus 12 pi over 12 is 17 pi over 12. That's between 0 and 2 pi, so that would be a solution. Lastly, let's check k equals 2. For k equals 2, I have pi over 12 plus 2 pi. Certainly pi over 12 plus 2 pi is going to be bigger than 2 pi. In fact, it's going to be 25 pi over 12. So that's too big. Same deal here. For k equals 2, I'm going to get 29 pi over 12, and that's too big. So my solution set is pi over 12, 5 pi over 12, 13 pi over 12, 17 pi over 12. Let me summarize what we did here. First, we found the angles such that the sine of the angle is 1/2. That was pi over 6 and 5 pi over 6. Then you add 2 pi k and 2 pi k because the period of the sine function is 2 pi. We set the argument equal to that expression, then solve for the angle theta. We get this expression and this expression. Choose values of k until you are certain you don't have any other angles that are solutions other than the angles listed in this interval.